So guys, we are going to continue the discussion with respect to statistics, and in this video we are going to cover measure of central tendency. Okay, in this topic we are going to cover three important subtopics, that is mean, median and mode. Okay, now in our previous topic we have already discussed about population and sample. So let's consider that I have a population of size capital N and sample size of small n. With respect to this, the mean or the average formula will change a bit. Okay, so let's discuss what is exactly the formula. In the case of a population data, if I really want to find out the mean or average, the mean and average is usually given by the symbol called as mu, and here the formula will be summation of I is equal to 1 to capital N. Okay, x of I, this x of I will just talk about it. Just consider that these are data points that are present in this particular population divided by capital N. Okay, so N is nothing but your population size. Similarly, if I really want to find out with respect to sample size what will be the mean or the average formula, I can write x bar is equal to summation of I is equal to 1 to small n, okay, x of I divided by small n. So this is the basic formula with respect to this. So I'm just going to highlight this so that you will be able to remember this formula every time. Okay, so this is the formula with respect to population size and with respect to sample size. Okay, now let's take a very good example and let's try to solve it. Okay, so for this, what I'm going to do is that I'm going to just consider a variable called as age. Okay, suppose in this age I have different types of ages. Let's consider that I have values like 1, 3, 4, 5. Okay, now this may be the population or sample. Usually population is not of so small size, so I'm just going to give you a basic example by just taking a small data. Okay, now if I really want to find out the mean, so what I will do, I will write mu is equal to, okay, summation of I is equal to capital N or summation of I is equal to 1 to small n. Okay, so what I'm going to do, summation 1 plus 3 plus 4 plus 5, right? So once I divide this by 4, then this is nothing but 3 plus 4 plus 4, 8, 8 plus 5, 13, 13 divided by 4, right? 13 divided by 4, which is nothing but 3.25. I hope I'm approximately right. 4 3s are 12, then 2.3.25. So this is basically the mean with respect to this particular ages, right? Now why it is called as central tendency? Because this is basically showing you the mean part of this particular distribution. Okay, distribution. So this is the basic formula in order to calculate the mean. If we are specifically told in a problem statement, then this mu will either become x bar in the case of a sample mean. Okay, very simple, very easy to understand. Now the second measure of central tendency that we are going to discuss about is that is called as mode. Before going with respect to mode, I am just going to consider and make you understand median. Okay, so what exactly is median? Now let's consider the same ages. Okay, so I had this specific ages like 1, 3, 4, 5. Okay, we know that the mean for this particular distribution or this particular ages is somewhere around 3.25. Okay, let's consider that I'm just going to add one outlier like 100. Now what will happen if I really want to calculate the mean? So it will become 1 plus 3 plus 4 plus 5 plus 100 divided by 5. Okay, now because the number of elements has now become 5. So the total value, if I try to calculate, it is nothing but 105, 109, 12, 13. 113 divided by 5. Now if I really want to calculate this, 5 2s are 10, 5 2s are 10, 22.6 is my average value now, right? Now you see this. Why? If I'm just using this outlier, suppose this outlier is basically added in this distribution, and if I apply the same formula, okay, if I apply the same formula of mean over here, you will be able to see that initially when I did not have this outlier at that point of time, my mean was 3.25. But as soon as this outlier or this big number, when it was added, right, I'm now getting the average mean of 22.6. Now this is obviously wrong, right? Because here you can see initially I was getting a small mean, now here I'm getting a very, very big mean, right? So mean value over here is changing by a lot values because I have a specific outlier. I'll be discussing about outlier in much depth and how we can basically use different techniques to remove it, okay? But just understand this. Now in order to overcome the impact of this particular big number, what we do is that we use something called as median. Now let's consider how does median work. Suppose I have this ages. Let's consider I've jumbled all these ages. So suppose I'll write 4, 3, 1, 5, 100, right? Now the first step in median is to sort the numbers. Okay, so I'm just going to sort the numbers. So after sorting the numbers, the number will now look at 1, 3, 4, 500, right? Now median says that instead of finding the entire average, you just pick up the central element, okay? Because I don't want this number to impact this entire distribution, right? So what I will do is that I'll just pick up the central element. Now central element, suppose if the number of elements that are present over here are odd, right? Now you can see that how many number of elements are present over here? 5, right? 1, 2, 3, 4, 5. And what is the central element of this 5? This third element, right? So median will basically pick up the central element. Now in this particular case, the median will be 3, right? Now understand why this will definitely work, because over here you can see my average was somewhere around 3.25, right? But here, even though the outlier or a big number was added, with the help of median, since I picked up the central element, sorry, the central element over here will be 4. Just a small mistake because, okay, 4, right? Because this is my central element, right? Now when my before mean was somewhere around 3.25, even though by adding an outlier like 100, if I get a median number as 4, it's still not getting much impacted because the previous mean was 3.25. It's just a small change, right? So median in short will actually help us to overcome from outliers, and it will not impact the distribution with respect to the measure of central tendency. This is very much important. Now you may be thinking, Krish, what if I add one more number? Let's consider that I add one more number. After 100, I add 200, right? So in this particular scenario, how do I, let me just write down the number once again, 3, 4, 5, right? Now in this particular scenario, since the number of elements over here are even, then how do I take out the central elements? Now in this particular case, guys, always understand the central element will be 2, okay, 4 and 5, and we can actually use this both element and we can calculate the average of this. Now once I calculate the average of this, it will be nothing but 4.5. Still you can see that the previous mean was 3.25, even though I did not add 2 outliers. Even though after adding 2 outliers, I am just getting a smaller impact in my measure of central tendency, which is very, very good, right? So in short, median will actually help us to fight against outliers up to some level. There are some more advanced techniques where we will try to see that how we should fix this kind of outliers as we go ahead, okay? The last thing, so median has been completed. There is also one more technique which is called as mode. So let's understand the third technique, that is called as mode. So mode will also help us to fight against outliers, but here how it will work. Let's consider one thing. Suppose I have elements like 4, 3, 2, 1, 1, 4, 4, 5, 2, 100, right? Now in this particular case, I have an outlier. So if I try to calculate the average, obviously it will impact this mean value, and it will not be similar to the central tendency value because of this specific outlier. So in the mode case, we actually select the mode process is that we select the element which has maximum frequency, element which has maximum as maximum frequency, right? Now in this particular case, if I really want to find out the measure of central tendency by using mode, my output will definitely come as the maximum frequent element over here. So over here you can see 1 is present 2 times, 4 is present 3 times. So I can definitely select 4 over here as my output, right? So even though there are outliers, mode will focus on selecting the most frequent element, right? So this was a basic understanding to make you understand about the measure of central tendency with respect to mean, median and mode. Please make sure that you know this particular kind of notations that we are using, mu, x bar, because as we discuss more and more things in the upcoming videos, we will be repeating this kind of concepts again and again. So I hope you like this session. We will continue the session and we'll discuss about the next topic that is called as measure of dispersion. Thank you.